morning.
Good morning.
How are you today?
Great.
You got a different camera, or it's in a different spot.
Yeah, I'm on my Mac today instead of my iPad.
Well, normally today is kind of like a holiday. Well, it's not really a holiday, but kids have the day off school. Not not because it's a holiday, but because it's one of those teacher professional development days. So they're all at home. One of them is sleeping, as teenagers are apt to do, and the other is up and about, the young one. It's funny with kids, probably with adults too. On weekdays, can't even get them out of bed at 7 o'clock. On weekends, however, they are up and about at 6:30. So that was basically the weekend. On Saturday, I was trying to sleep in, and the young one comes in, and I go, "What time is it?" He's like, 6:30, and I'm like, "Oh, that's right, it's Saturday. You're up." But come Tuesday at 7 o'clock, you'd be like, "No, I'm not getting out of bed. It's too early." I'm sorry I wasn't here on Wednesday. There was a video for you to watch that answered some of the questions about the CSI assignment, and also went through how to basically decode a JPEG from start to end to look for those starting markers and then the markers in the middle of the file, and finally reach the one at the end of the file. And I'm wondering, did anyone take an opportunity to try to implement that?
Yes.
You did?
Yeah.
Did it work?
I think it worked.
Wow.
Seems like it worked, and it uncovered a bug in my finding the end of the files the other way.
Oh, and so were you able to find a file that you normally wouldn't have found one?
No, but they were a lot shorter, or at least a little bit shorter than the other ones. And so I looked at the other ones and realized I had a bug where I had an and where I should have had an or. So it stopped when it found an FF, not an FFD9.
Oh my goodness. So now you've uncovered all the files, is that correct? And you've got how many?
Yeah. 29.
29.
Yeah, my initial problem with not finding all the files was I had a stupid typo in the code that looked for the header.
Mm-hmm.
I looked at index 0, 1, 2 for the first 3 bytes and index 3 for E0, and I typed index 4 for E1, and so it never found the files I had in E1. So once I saw that, I found all the files.
Yeah, so it's E0 or E1, but both at byte 3.
Right.
Yeah.
So it's just, I was just going through typing 0, 1, 2, 3, and it just kept going and typed 4.
Well, good. I'm glad you were able to implement that. And was it kind of neat watching the program kind of hop through the file and find all the pieces? I mean, I remember the first time I did it and I got it to work. I was like, wow, that's cool. It did take me a while to figure out that whole, those reset tags, the ones that appear in the middle of the image data. At first I thought, well, I can just ignore those, right? I mean, they're not part of what I'm looking for. I'm looking for the ending one. But it turns out you need them in order to hop. Is that correct? You need them in order to hop successfully, because there's a tag that marks the beginning of the image data, but the length it gives you is not the total length of the image data. It's just part of it. So you kind of have to ignore that and just use those reset markers to hop your way through the image data to find the end of it.
Yeah, oh, sorry about that. Yeah, I think I found them and ignored them in the image data, and that seemed to work. Just when I found one, I would just keep going from there until I found a marker that wasn't one of those reset markers.
Well, at that point, you're looking specifically for the ending one, I think, or
Oh, I didn't necessarily. I mean, the way I wrote it, it could have been any
Oh, that's true.
marker.
Yeah.
If it, you know,
Yeah.
if it found a comment marker at the end, it would skip that.
Yeah. Well, that's cool. How long did it take to implement all that?
Um, that was about an hour.
Yeah. Is that an hour of actual coding or an hour
Yeah.
of thinking about it and then coding?
Well, I probably thought about it overnight while I was asleep.
Yeah.
You know how that works. You wake up
Yeah.
and
That
something comes to you.
that tends to be kind of a big difference between someone with more programming experience and someone who is just starting out. Is the person just starting out tends to just dive in and start coding, and the more experienced person, kind of based upon that experience, realizes the actual coding itself is what you do at the very end. It's just thinking about the problem and how to solve it that kind of takes up most of your time. And so, like you said, a more experienced programmer might look at a problem they need to solve and then think about it for an hour or two or even overnight, and then actually hop in and start doing the programming at the very end. And so I tend to find that I'm kind of the same way myself. I'll spend a lot of time just kind of mulling it over in my head, and then once I kind of reach a conclusion about how to actually code it, then I'll start sitting down and coding. And sometimes I realize after coding it for a while that my approach was incorrect. But in the process of actually coding it, I've learned a little bit more about the problem. I've learned about some of the kind of ins and outs and the little edge cases. And then sometimes I might have to do it again after thinking about it some more. So you said it's an hour of coding, which for an inexperienced person might go, wow, that's really fast. But you kind of have to add on the 3 or 4 hours you spent just mulling it over in your head. And then that's the total time. And so, really, it could be that the total amount of time you spend on a problem isn't that much different than what someone just starting out would do. It's just that the person starting out starts coding right away and then spends a lot of time thinking while they're coding. And they might end up spending 4 or 5 hours on it. And the more experienced person might also spend 4 or 5 hours on it, just that they spend 3 or 4 thinking about it, and then 1 hour of actually doing the coding. Does that kind of reflect your experience?
Yeah. It's definitely kind of running through it in my head while as a kind of background process. Kind of, I'm running. Yeah, just kind of running through the loop, kind of visualizing how I'm going to write it.
And sometimes you can do that while you're just going about your day, right? You're just
Right.
fixing dinner or doing some yard work or something, and then every once in a while your brain just starts thinking about the problem and churning on it. And then, of course, there's always that inspiration you get while you're in the middle of doing something else. You're like, oh man, I got to remember that, right?
Yeah.
Anybody else working on the assignment? Has anyone run into difficulties with it where they're just like, I can't figure out how to kind of get past some sticking point that you're having? You've got it maybe finding the number of files, but you can't really find the end of each file successfully. I'm gonna duck out of here for a second, get my computer. There we go. So as far as a technique for finding the ends of these files, kind of gave a big hint in the in the assignment that said that the SD card had been formatted right before I started taking pictures, which means that the SD card is basically filled with a bunch of zeros, more or less. And then the image data starts, or the JPEG files start being laid out end to end almost on the SD card. And they're not necessarily in consecutive blocks. In other words, the files themselves are in consecutive blocks, but the file number 2 may not follow immediately in the block right after file number 1. There may be a couple of intervening blocks before it starts laying down the next file. But once it does lay down a file, it does go in consecutive blocks. So one of the things that might work for you you're having trouble kind of getting things going, is to do something like this. Well, not that. There we go. So let's say, SOI means a start of image. And that's that 4-letter byte sequence that we're looking for. And then EOI, end of image. So if you're trying to find the start of the image, you can just simply scan forward through the file until you find that 4-byte sequence. But since the start of image is always going to start at the beginning of a block, you don't have to look at every single byte as you go through the file. All you have to do is look at the bytes that correspond to the beginnings of blocks. So you can kind of skip your way through the file. You don't have to look at every single byte. You can look at every 512 bytes. So a way you might write a loop to do that is like for I equals 0, I is less than the length of the file. And then go I plus equals 512. So you're not incrementing I 1 byte at a time. You're going up by 512 bytes. And that can make it a lot faster to scan through the file looking for these start of image markers, because they're only going to occur at the beginnings of blocks. So once you do find a start of image marker, then the goal is to find the end of image marker. And the trick there is not to find the ones in the middle of the file, but to find the one at the end of the file. And so one technique that's been pretty successful with most of the students is, rather than scanning forward to find the end of file marker or end of image marker, you actually scan backwards to find it. So you'll look for the start of image marker, and then you'll look for the next start of image marker. So find a start of image marker, find the next start of image marker, which you know is going to occur at a 512 byte boundary. So you're going to bound forward again by 512 bytes until you find that next one, and then scan backwards to find the end of image marker. So scan backwards from the next start of image to find the end of file marker for the first image. And you're going to be able to scan backwards because there's just going to be all zeros there. So you kind of we'll just go backwards, and you can either just look for this end of file marker, which will be the 2-byte sequence, or you could just scan back through all the zeros until you find the end of file marker, end of image marker. So now you've got the start of image marker and the end of image marker, and you know where they are. You've got the indexes of each one of them, and now you need to compute the length. So will it work to simply subtract those two markers? Can I just take the end of image marker index and the start of image marker index and just subtract them? Will that give me the correct answer? Oh, my neighbor's cutting down trees again. Gotta close the window. It's fall. It's tree cutting time. So will that work? Can I just subtract the index of the end of file from the index of the start of image? Actually, I can reverse these around. And the answer is no, it won't. You know, let's say, let me just do this. Let's just go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's say, just with these numbers here, let's say I found the one relevant location here at index 10, and I found another relevant location at index 4. So let's say something starts at 4 and ends at 10, and I want to know what's the total length of this. Can I just subtract 4 from 10? Will that give me the right answer? Well, if I subtract them, I get 6. But let's see how many indexes are actually involved. I got 1, 2, 3, 4, 5, 6, 7. So the total length is 7, but if I subtract them, I get 6. So you can't just subtract them. You'll end up chopping off one of the bytes. So it's going to be more like end of file index minus start of end of image index minus the start of index plus 1 equals the length. So once you've got the length calculated correctly, you can then call save JPEG using that computed length. So you're going to give it the basically the address of where the image starts, and you're going to give it the length, and then you're going to give it the file name you want to use.
And EOI there's that's the second byte. That's the address of the second byte of the EOI.
Well, it depends upon how you find that. Yeah, it could be the second byte. If it's the first byte, then you probably need to add 2 to this. Is that right?
Right.
But regardless, my point there was you can't just simply subtract them and get the right answer. You might be off by 1 or 2 bytes. So if you're struggling with the assignment, that technique could work pretty well for you to really find the ends of the files. Now, another thing you could do, and I also dropped a hint for this, I think, in one of the live sessions we did last week, and that is I said none of the images are over 2 megabytes in size. All of the images are smaller than 2 megabytes. And I also said that if a JPEG file contains more information than just the JPEG, so if it's the JPEG plus some extra stuff, the JPEG viewer won't care. Once it finds that end of image marker, it'll just ignore all the rest. So if you're having trouble finding the end of image marker, you could just do this. Just call save JPEG with the address of the start of image marker, which is easy to find. And then for the length, just put in 2 million. And you're guaranteed to get all of the image plus some extra. Who knows, you might even pick up 2 or 3 or 4 images. But the JPEG viewer won't care. It's only going to look at the first one. So if you can find the address of the start of image, you could just pass in 2 million for the length. You'll get a whole bunch of really big files. They'll all be 2 megabytes in length, but you will get all the images. So you could do that, and at least you'll get the images. You won't, you know, the goal would be to actually winnow it down to the correct size, or really as close as you can to the correct size. So, but at least you could do this, and at least you could know that you're pulling the images out and you're finding the start of image markers correctly.
I do have a question.
Yeah.
I believe so. I was using like I wasn't using Thea when I first started this assignment, and I noticed that I was looking at that hex edit, thing with the JPEGs that it was pulling out,
Uh-huh.
and it didn't seem to work on my own computer, but it worked on Thea, which was very strange.
Hmm.
I'm not sure. I mean, I did change it a little bit, but the thing that was weird is that it was just pointing to the file location on my computer of where all of my like C files were and everything, but it wouldn't have any of the JPEG data in there. It was kind of strange. But then when I did it in Thea and changed it like a few things, then it pointed to the correct thing.
So you're talking about using that hex editor? That didn't work?
No, it did work, but when I had kind of the same code in my own
Hmm.
computer, then in Thea it had two different outcomes. So I'm not. I was kind of. I was like, huh. Okay. Well, I guess I got to use Thea from now on, not
I
my own
guess I can't.
setup.
I can't just off the top of my head explain why you would get different behavior.
Yeah, I'm not sure either.
Incidentally, what are you using on your end?
I let's see. Well, I have like I downloaded. I can't remember what it was at this point, but I'm using like a C-Lang Clang compiler.
Mm-hmm.
It was the closest thing I could find to like all the stuff you're using on Thea. Just running it through Ubuntu.
So you're running on a
But I'm
Linux
not,
environment. It's not like
yeah,
you're doing Windows or.
no, yeah, it's on a Linux environment. Yeah, but it's working now. But I did think that that was kind of odd at first.
Mm-hmm. Considering that the Thea is running on a Linux environment too, you're doing all your programming in Linux there. Even then, it shouldn't make a difference.
Yeah, yeah,
Are you doing
weird
it from
thing.
the command line?
Yeah,
Okay. Have you, because I mean, Thea is a lot like Visual Studio Code. I think it might be Visual Studio Code under the surface. Have you tried that?
what do you mean?
Um, it's the open source development IDE from Microsoft. It's called Visual
Oh yeah,
Studio Code.
yeah. No, I do have that. I was just doing it in NeoVim at first, but then I have it.
Okay.
I now have it in yeah in VS Code.
Huh, how strange. So when you were doing it on your computer, it was not successfully pulling out the images at all?
So it would give me like the starting bytes and the ending bytes and all the data in between. But then when I would run that into save JPEG, it would just be a blank. It would just be a blank image. And then when I put that JPEG that it saved into hex edit to see what it says in there, it was just like it was just the file location, which I was like, huh, that's odd.
And you would get the files out of it, they would just be like
Yeah,
blank
they
or
would just be blank.
unviewable.
Yeah.
Do you know the sizes of them?
Not off the top of my head now.
Like, oh, I'm curious to see if they were all zero. Like, was the sizes all zero?
Yeah, when I get home later, I can I'll start it back up and I'll let you know.
Yeah, I can't think of any other reason why it would do that. Like, I could see maybe if it was a text file rather than a file containing a bunch of images, because there's different ways that different operating systems handle text files.
Hmm.
But a file like this shouldn't make a difference.
Yeah, I think I was probably just
Yeah.
doing something wrong. It's probably what it was.
Hmm. I guess it would be interesting to see what was going on your computer. Like, without being able to see it, we're just speculating on what it could be.
Yeah.
And who knows, if we saw it, we might just look at it and go, yeah, I can see what the problem is. And then I would file that away in my little notebook of things that might happen to students.
Mm-hmm.
Any other comments about that assignment? I hope you did find it to be interesting. I deliberately left the actual techniques to use kind of vague so that you would be able to kind of, put on your own thinking cap and try to figure out how to solve this problem without a tremendous amount of direction to follow. Okay, so today we're going to introduce something that has nothing to do with actual programming, but is one of the tools that software developers use. And I guess before we begin, I want to take a quick survey of the people who are here live, and that is, has this ever happened to you? Let me. So have you ever accidentally deleted your program? Anybody? I sure have.
Yes, definitely.
I've actually deleted my program just hours before it was due. And it was not a small program. It was a long, long program. I accidentally deleted it. Have you ever wanted to go back in time? And retrieve a previous version of your program? Like you were working on it, and then you tried to fix a problem, and you broke it. So you want to be able to just basically undo everything you did in the last hour, go back to that previous version.
Definitely.
Yeah, absolutely. Have you ever collaborated with another programmer on a program? And this may be something that some students have not done. Most of your assignments are individual work, but occasionally you've got to do some group work. And it comes up later, it comes up more and more as you move up through the courses. You get to things like data structures, compiler design, artificial intelligence, and then sometimes the assignments just get too big for one person to tackle. So you need to work in pairs or in groups of 3 or 4 to be able to get the work done. Because you've got to be able to split up the work among several people, or you just need several people to kind of toss ideas around and and do the work. People are saying, tell us the story again where I deleted my files. Sure. Actually, I've got several stories like that. So the first one happened when I was in college, kind of like a lot of you. And this was the one where I deleted the files just before it was due. And so I think for some reason the professor made the assignments due like at 8 a.m. It's just crazy time for it to be due, which means a lot of people are up all night working on the assignments. And this wasn't like first, second year stuff. This was like third or fourth year stuff. So I think it might have been a data structures course and working on some program to build a large data structure and then do something with it, like sort it or search or something like that. So I've been, and back then also, we had computer labs on our campus, and that's where most people did their work because it was very unusual at that time for people to have their own computers. They were really expensive and they were slow, and you couldn't really do your schoolwork on them because you didn't have enough memory, you didn't have enough whatever. And so most students went to the computer labs, which was a great place to go because now it was a big social event. You could go, order pizzas, bring some soft drinks, candy, and just sit up all night working on your assignments. And there'd be 20 people in the computer lab all working together. And then I guess it was around 4 o'clock in the morning when I decided that I wanted to recompile my program from scratch. Right, I just wanted to basically remove all of the compiled versions of the program and just recompile everything. And so the way you do that is you type rm for remove and then *.o, which removes all of what are called the object files. And I didn't type that. I typed rm space star space .o. So I put an extra space in there. And I pressed enter. And now, of course, back then computers were slower. So these days, if you did that in a directory, you'd get your prompt back almost immediately. But back then, it took, you know, a second or two before it came back and said, no such file or directory .o. And at first I stared at that and I went, what does that mean, .o? And I went, oh my gosh, I've accidentally just deleted everything in my directory. And on a Linux system or Unix system, there's no like undo, there's no undelete the files. Once they're gone, they're gone. There were backups being kept, but the backups are only run like once a day. And so you might or might not get your files back if you went to the computer operators and asked them for backups. And of course, the assignment's due in 4 hours, and there's no way I can get backups retrieved because the office doesn't even open, you know, until 8 o'clock. So I think I cried for literally cried for a couple of minutes. And my friends came over and went, ah, that stinks. You just deleted everything. And then there was basically nothing I could do except just start over again. I mean, that was my only recourse, was just start typing it in all over again. And I finished. I actually got it to work before the due date. And I learned actually 1 or 2 important lessons that night. One is, you know, make backups. But the more important lesson was sometimes, or actually very often, version 2 is better than version 1. You see, it took me, you know, most of the previous day to cobble together version number 1 to the point where it was mostly working. I still had some debugging to do, but, you know, I was getting near to the end. Version 2 came together in just a matter of a couple of hours, and it worked almost perfectly the first time. Because in the process of doing version 1, I learned a whole bunch about how the program was supposed to work. I found all the edge cases. I found you know, how to build the data structure correctly. That was all stuff that I had to learn and fix in version number 1 until I could finally get it to work. And even then, parts of the code were literally just kind of bandaged together. I would find a bug and then put an if-else in there to address that situation. But when I coded it the second time, I was able to incorporate all of those things that I learned right into the code from the start. And the code ended up being more compact, more concise, and worked correctly. And I was actually quite impressed myself with how well that came out. And so I think that was the bigger lesson there, is that sometimes you really do need to just delete everything and start over again. And then the second version will be better than the first version. So I learned to kind of not to be afraid of once in a while deleting everything. You know, it still hurts when it happens, and it doesn't happen very often now because now we have computers that just make automatic backups. Like, you know, my Mac has Time Machine, so I can always find something from an hour ago on there. You know, don't be too distressed if you lose all your work for a particular assignment, because the next version will be better than the first version that you wrote. So that was while I was a student doing an assignment. And then there was another time I got a job at the computer center at my university. And after a couple of years of working there, one of the sysadmins came over and said, hey, you know, I need some work done on this system. You want to tackle that? And I said, sure. So he gave me the task I needed to do. And then along the way, I did another remove command, but this time I did it in the root directory, right? I went rm like star in the root directory. And I expected that command to only take like a second to run because I was just cleaning out one small directory. But when it started taking like 10 or 15 seconds to run, I realized what I had done. That it was systematically going through the file structure and deleting all the files from the system. in particular, and because it works basically alphabetically from the top down, one of the first directories that gets deleted is the /bin directory, which is where all the main programs are kept, like ls and cat and all the basic commands that make up a Linux system are stored in that directory. So when I finally pressed Control-C to abort what it was doing, and then I typed ls to see what damage had been done, it said ls, command not found. And I realized that I just deleted like all the basic commands from the system. And so and this was a Unix system the university had, but back then the Unix systems were large and expensive, and there weren't very many of them. And so I was working on a system that fortunately was not like a production system, but nevertheless it was one of the dozen or so that they had. And so I went over to the senior sysadmin and I told him what I had done, and he said, well, I'll give you until the end of the day today, 5 o'clock, to get that system up and running again. I mean, it basically was throwing you into the swimming pool without any training. I'd been using Unix by then for many years, so I was pretty comfortable with the command line. But for him to say, like, okay, you have basically 4 or 5 hours to do what you can to get that system up and running. And then if at the end of the day you haven't got it going, we'll just restore from backup tapes, no big deal. But see what you can do. And that was a really cool experience. How can you get a system that was kind of crippled at that point up and running again with nothing more than just the terminal window you've got open to it? And he said, oh, by the way, don't close that window, right? Because the shell command, the actual file that contains the executable for the shell, is gone. So if you log out and then log back in, you won't be able to get back in because the shell doesn't exist. But as long as it's held in memory, as long as it's somewhere in the computer's memory, it can continue to run. So your shell is there, your command prompt is there, just don't log out. And I was like, okay, well, what can I do? And so he showed me a couple of tricks. And to this day, I still remember some of these tricks that he showed me. Like, if you're on a command line shell here, and you want to see a listing of the files that are in a directory, but you don't have the ls command, like if you type ls, it will say command not found. What can you do? And so one trick he showed me was go echo star. Echo is a built-in command. There is an echo command in the file structure, but echo is also one that's built into the shell. So it doesn't have to go and launch a new program just to run echo. And then star here basically just expands out to be a list of all the files that are in your current directory. Yesterday I was doing or last week I was doing a demonstration of RSA encryption, and so that's why you see all the stuff about passwords on there. But that was a useful command right there, just echo star to get a listing of the files in the current directory. You can't necessarily tell whether it's a directory or a file or how big it is, but at least you can see something. And then the next thing was going to be, how can I get some of these basic commands over onto the system? Like, how can I get ls again? And how can I get things like chmod? And so even though the bin directory was deleted, I think it hadn't reached the user bin directory yet. And the user bin /user/bin or /user/local/bin is where things like the compilers were installed. And so I had access to the compiler, but not to the basic commands. And so one of the first things I did was to write a quick little C program that would just like, you see, if you're going to write a program and then be able to run the program, you have to change it to be executable. And I don't have the chmod command, right? Because that's been deleted. But I do have the compiler. And when the compiler generates its executable, it has switched on that flag onto that file. So one of the things that, so one thing I could have done was I could have written a quick little program whose job it was just to change the execute permissions on a file that I named on the command line. So basically I could like call it, make exec. And then the C program would just call the built-in chmod library function and just switch on the execute flag. And then run that, compile that, and now I've got a program that can be used to turn the execute bit on a file. So the next job then is how do I start bringing over some of these files that I need, like ls and rm and things like that. And one thing I could have done is since we were running Unix systems, we had a couple of other identical Unix systems. And so one thing I did was, or tried to do, was basically copy over the bytes from like the ls command on another system onto this one, just using basically copy and paste. So can I like open a window to another Unix system, basically dump out the bytes for like the ls command, and then copy and paste them onto the window for this one that's broken, and get this one to work. And I think I was sort of successful at that, because if you just dump out the bytes, of course you're going to get a whole bunch of stuff that's like just gobbledygook. It's not printable characters. It's control characters and stuff like that. And so I basically had to like dump it out in hexadecimal, and then figure out how to bring it over and then unhexify it. Again, another C program that I wrote to do that. I was somewhat successful doing that. I think another trick that I learned was the compiler makes an executable, right? So now you got a file with the execute permission on it. But what you could do was, once you have that, you could then replace the contents of that file with a different file, right? As long as you keep it the same file, you could basically just erase the contents of that file and replace it with different stuff. And so that was another way that I tried to get like the ls command in, was now that I have a little program that's an executable, could I then just replace the contents with the bytes from another program? And now I have an executable version of ls. So like all this like stuff that I was trying to bring the system back from the brink of death. And finally, the end of the day arrived, and I had been marginally successful. And the guy came over and said like, well, did you learn a lot? And I said, yeah, I sure did. He goes, okay, good job. Basically, you could go at this for hours and hours and finally bring it back. But ultimately it's faster just to go to your backup tapes and restore it. So he took care of that for me. But that was a great learning experience to just, it's kind of like you've got a car that has broken down, and it not only broken down, but the engine fell out a mile back. And how can you get that car going again with just the toolbox you've got in your trunk? That kind of analogy. So that's a couple stories about accidentally deleting stuff. And I have other stories about accidentally deleting things on production systems, while users are using it. It all kind of like goes with being a system administrator and a programmer. And no one's completely immune to it. Even the big companies occasionally have problems like that, where somebody accidentally deletes a file or misconfigures something, and then everything just completely breaks. Some of the big internet outages are due to just somebody mistyping a command. And you'd think that there would be safeguards in place, but some things are just like single points of failure, where if you misconfigure one thing and nobody double checks your work, then it can bring, like, in some cases, entire parts of the internet down. Because the internet is not like this monolithic network that has overseers that make sure everything's running smoothly. Instead, the internet is built up out of much smaller networks that are just interconnected together. And it all kind of relies on everyone playing the game fairly. And if somebody does something to, let's say, divert more traffic towards them or away from them, it can destabilize the entire internet. And it's really all kind of on the honor system that people won't do that. And it has happened in the past, accidentally, where a small ISP somewhere has accidentally advertised out to the internet, hey, send all traffic to me. And they did. And it brought that ISP down, and it brought the internet down in that part of the country, right? Because basically all the internet's traffic was flowing to one small internet service provider. You know, these days, that sort of stuff is protected against because they don't want that to happen again, right? So if other ISPs discover that someone is advertising out to the internet, send all traffic to me, they'll just kind of ignore that. You know, as a lesson learned from that particular incident that happened, I think it was about 20 years ago or so. Anyway, so we're going back to what we were talking about a moment ago, which was version control systems. So a version control system can address all of these things that I'm talking about on the screen, like have you accidentally deleted your programs? Well, a version control system will make backups for you. And have you ever wanted to go back in time and retrieve a previous version? Yeah, a version control system, not only because it's making backups, will keep a running log of those backups. So every time you make a backup, that's a particular point in time that you could go back to and retrieve a previous version. And also version control systems allow you to collaborate with other programmers by not only doing things like access control, who can collaborate with who else, but also managing, being able to merge file changes together. You see, if you just did file collaboration by doing sharing on like Dropbox, then the problem there is that whoever basically saves the file most recently rules the roost, right? Because you'll overwrite the changes that someone else did. But a version control system can take all the changes, all the edits that programmer A did to a file, and merge them in with the edits that programmer B did to that same file, and make sure they don't step on each other's toes. So some terminology that you should know about. There is a working directory. And a working directory is basically where you are doing your editing and compiling and running your program. And that's as opposed to the repository. And that's where the backups are kept. So the repository contains what are essentially snapshots of your working directory over time. So you got your working directory, you've got your repository, and oftentimes those are fairly close to each other. The default behavior for the version control system we use is to put the repository right below the working directory. So your working directory is up here, the repository is right below it. So if you delete your working directory and everything inside of it, you'll also delete the repository. But on other systems, they might be separated, so that accidentally deleting the working directory does not affect the repository. Okay. When you are actually doing your work and you're wanting to work with that repository, you can do a commit. And a commit is making a snapshot of your files. Basically, make a backup. Rollback is to undo a commit. So basically, you save your files and then you want to go back to a version. You can do a rollback. So you can roll back time and find a previous version. Stage is to prepare a file or files. because as you're working on a program, let's say it's a large program with several source files. As you make changes to one of them, you'll want to remember that this one is one that you want to do a commit on later on. So you can stage it. You can basically tell the version control system, this one is ready for a commit now. And then you work on another file, and then you stage that one. And then finally you do one commit that takes all the files that you've worked on and then makes a backup of them all at once. Push is to take the files in your local repository, the ones that are on your computer, and send them up to another computer. And the opposite of push is pull. And I might mention here that when you do a push and a pull, it doesn't upload your entire repository. It only uploads the changes since the last time you did a push or the last time you did a pull. So doing version control systems are all about finding differences between what you have now and some other point in time. So when you do a commit, it doesn't actually make a copy of all of your files. It just figures out what's different between the file the way it looks like now and when the last time you did a commit, and it saves that. So the first time you do a commit, it will make a copy of your file, but then subsequent commits are just small little snippets of code that say like line 5 changed, and line 10 through 15 were deleted, and lines 30 to 40 were added. So the commits tend to be very small. And then when you do a push and a pull, it's also just simply sending up or bringing down just the changes since the last time you did a push or a pull. And then a clone is to make a complete copy of a remote repository. So you might do this if you are, let's say, working on a software project and someone else has created a repository of some work that's already been done, and now you want to join that team. You will then clone that repository down to your computer so that you can start working on that code itself. Okay, so we've got working directory and repository, and we've got commit, rollback, and stage, and then we've got push, pull, and clone, and those are going to be the major terms and the major commands that we're going to be using. So as far as an actual version control system to do these things, there are several out there. There's one called Git, which is the one that we're going to be using. There's one called Mercurial. There's CVS, and there's a few others out there, but this is I would say by far the most popular one is Git, perhaps followed by Mercurial, and then followed by CVS. So we're going to use Git because it tends to be pretty popular. It's not like the totally easiest one to use, but it is the one that you're most likely to find help for if you do run into trouble. So all of the version control system commands that we're going to use start with the word git. It's git followed by some verb. So the first one that we need to learn is git init. And this is used to initialize, or I should say it's used to prepare a working directory for version control. Basically what it does is it creates a repository. So if you're in your working directory, it then creates a directory for the backups and then sets up the databases inside there. When you're doing version control, it is important now to be more organized about your files. You can't just throw it all into one directory and then kind of sort through it visually. You're going to have to be more disciplined about it. And that's basically going to mean putting all the files related to a particular project or a particular assignment in one directory. So we're going to be doing that basically from now on till the end of the semester. Rather than throwing everything willy-nilly into the home directory, we're going to start putting things into subdirectories and keeping things more organized. And this allows us to have a working directory for one particular assignment, so we're not being distracted by the files for a bunch of other things. And it also allows us to have a repository for that one assignment where we're keeping our backups. And so git init is used to do that. It's very important to do that git init in the working directory for that assignment, not in your home directory. If you do it in your home directory, there's a possibility that you will commit everything, all of your files, into one repository, and you don't want that, right? You don't want to clutter up your working or your repository with a bunch of files that are unrelated to what you're working on. I will show you on Thea how to make it a little more foolproof so that you don't accidentally do a git init in a place where you shouldn't do it. There's git config, which is used to tell Git about you. Every time you do a commit, it's tagged with your name and your email address. This is so that if you are collaborating with somebody else, they can keep track of who did what to the files. So we'll do git config -- global user.name. And then in quotes, you put your full name and git config -- global user.email, and then put your email address. Git is not going to check to make sure any of those are valid, so you can put whatever you want there. In other words, you don't have to put like your student email address. You don't have to put a particular username there. It would just put your name and put the email address you use most commonly. The whole point there is that, again, if you're collaborating with somebody else and they need to contact you about a change that you made, there's your name and email address there so they can send you a note. Okay, git add, and then a file name is how you stage a file. Remember, that means to prepare it to do a commit. And then git commit -m and then a brief message in quotes is how you do a commit. And all the commits are tagged with a brief message so that you can kind of record what you did since the last time you did a commit. Those are really important because if you want to find a particular version, let's say you're working on a larger project and you fixed bug number 632, then you'll want to put in that message, this is the fix for bug number 632, so that someone can go and find that version to be able to incorporate it into the production code, let's say. We won't talk about doing rollbacks just yet. Let's just get the basics down. So we got git add and git commit along with git init and git config. So I think at this time we should probably show you git actually being used like in real life. So let's log in. And we got a whole bunch of files here. I think what I want to do is I want to take some of these existing files that I've got and put them into a, actually here might be a good one, this image one. We didn't actually do see, do I have anything here? I do. No, actually I won't do this one. Let's do, what do we got here? I'm trying to find something where I've got like a bunch of files to work on. Huh. Oh, I don't have much to work with here. Well, why don't we just do all this stuff related to, didn't I do some stuff with the TV? And was this diagonal? Oh yeah, here, diagonal. Yeah, let's do stuff with the TV. And then, so I got my TV files here, and then didn't I do another program related to that? I can do a quick search here. TV. Oh, desk. That's right. So I want to put all that stuff related to the desk and the TV stuff in one directory. So let's go ahead and do that. Let's see. Let's make a new folder, and let's call this all the stuff related to doing diagonal calculations. And let's drag everything into that folder. So here's the desk. Oh, I can't reach it. There it is. And the diagonal stuff. Oh, it's going to be a problem here. This drag and drop is a little difficult to do. Because I can't reach this from here. Let's see, can I do this? Can I go copy and then paste? Nope, that doesn't work. I'm just going to do it from the command line here. Let's move all the TV stuff into diagonal. Okay, so now I've got all the files related to computing TV size and desk size all in one directory. So I want to make sure that I don't accidentally, see, the next thing I need to do is I need to go get init, but I need to make sure I don't do that in my home directory. So if you're, reasonably cautious, you can do something like cd to diagonal and then do your get init there. But it's really kind of, for beginners, I've noticed that it's easy to make a mistake and to do this in the wrong spot. So what we can do is we can highlight that directory, and then we can say open workspace. And we can select diagonal and then click on open. And so now what we've got is a separate tab that is just the diagonal directory. Let me show you what I did there. I went to, I don't actually have to highlight diagonal here at all. I can just go to open workspace, select that directory, and click on open, and then I'll get a new tab that is just that directory, nothing else. All my other stuff is still there, right? I can go back to the other tab and see everything. But this tab over here is just my diagonal directory. And when I open up a terminal, it will be in that correct directory. So this would be a good way to make sure that you're not doing anything outside of the directory that you shouldn't be doing. Now I can type git init, and it says it initialized a directory in there, and a repository in there. And then I have to do my git config. You only have to do this once. You don't have to do the git config just once. And then now we're ready to do our first commit. Let's see, we have been working on these files a little bit, but we haven't put them under version control. So the first thing to do would be to go ahead and commit all of these files. So before I do a commit, I should make sure that these files are actually like usable. Make sure they actually compile, because what you don't want to do is you don't want to commit into your repository files that just don't work. So let's go ahead and actually compile the program and make sure it works. Enter the width of my desk. Let's say it's 42 inches wide. Then each monitor should be 24 inches diagonally, and then by 2 of them. Question here is, how is that possible to run git commands in your directory? So there's 2 things you can do, if I understand your question correctly, is you can use the cd command to change into that directory and then run your git commands there. Or if you're using an IDE like Visual Studio Code or ours, which is Thea, you can open up a workspace in that directory, and then it'll just automatically place you in that directory whenever you do your work. What would happen if you did a git commit in your home directory? Here is, it would initialize a repository in your home directory, and then everything that you did a commit on, even in a subdirectory, will go into that repository. So when you finally end up pushing it up to me so that I can look at it, I'll see everything. And I don't want to see everything. I just want to see the stuff for your current assignment. Also, if you do a git init in that home directory and then you go into a subdirectory and do a git init there, it'll come back to you and say, hey, you've already got a repository. I'm just going to use that one. So it's important to do a git init in the directory that is for your project or assignment. And that's why I'm showing you how to open up a workspace so that it isolates, visually isolates you from the other directories. Okay, so I made sure that the desk program works, and let's also make sure that the TV program works. So if the width is 48 inches, then the diagonal is going to be 55, and that looks good. So now I'm ready to do a commit. Now, I've got a bunch of files over here. I've got a.out, desk.c, diag.c, diag.h, tv.c, tv.o, left over from a previous experiment, and then tv.s, also left over from the previous experiment. So which of these files do we actually want to do a commit on? Well, a good rule of thumb is only commit files that are your actual source files. Everything else, like the executables and the object files, those can be built out of your source code files. So you don't really need to commit those. So I would really kind of discourage you from going git add star, because you'll end up putting into your repository files that can be recreated. In particular, like the executables. Like if you do a git add star and then commit everything, you're going to end up putting into the repository the compiled executable. And then when I go to run your program, the first thing I'm going to do is recompile it from scratch, right? I'm not even going to look at the old executable. So I'm going to end up throwing that away. So there's no point in adding that to your repository. Don't commit anything that can be recreated. So what you should do instead is just to go git add, and then I would suggest just individually adding the files that you want, which are going to be desk.c and diag.c, diag.h, and tv.c. And these aren't going to do the commit. These are just going to mark them for a commit. You can see over here that the ones with the A have been added, and the ones with the U are unstaged, which means that they have not been committed, and we're not going to commit them. Now we'll do git commit -m, and since this is our first commit, we'll just say this is our first commit. And the little markers went away from those files, indicating that these are now stored away in your repository. Okay, so we did a git init, we did git config, we did git add, and we did git commit. Now, what we can do now is, since we've made backups, we can feel free to make some changes to things. So let's say we go to desk, and let's say we want to change this so that it doesn't print out the width of the monitor out to like 5 decimal places. I just want 1 decimal place. So this would be percent, what is that, 0.1f. Save it. Let me recompile it, make sure it still works. And then that looks better. So now I am confident that I have a working program, and I can now do another commit. So we can look over here and see that desk.c has been modified. So that's the one that we should be adding. Nope, not Clang. I want to do git add desk.c, and then git commit -m, and then a brief message describing what we changed since the last time we did a commit. So the thing we changed is we changed the format of the monitor diagonal. So we could say like monitor size is now rounded to 1 decimal place. So this is how you could do your work. As you get more experience with version control systems, you'll learn that it's not about making backups so much as it is kind of protecting against protecting against common things like I want to go back a version or I want to collaborate with somebody else. So what I've discovered in using version control systems, before you use version control systems, it's kind of like you sit down to do your assignment, you plug away at it for a couple of hours, and finally you get to the end and you upload it to Canvas and you say, I'm done. Along the way, you probably did work in this part of the file and then this part of the file. You kind of like just, as problems came to mind, you fixed them, and then you went on to another part of the program. But once you start using a version control system, what you're trying to do is figure out how can I get from the point I am now to the point where I can do another commit. Because you want to do a commit every time you've got a working program. It doesn't have to be done, it doesn't have to be finished, but at least it ought to be compilable and be making progress towards your end product. So you might look at your program and go, I see 2 bugs that I need to fix. Maybe one of the bugs is the output needs to be rounded to 1 decimal place, and the other problem is I'm not doing the calculation correctly. So I'm not going to fix both those bugs and then do 1 commit. I'm going to fix one of those bugs and then do a commit, and then fix another bug and then do a commit. So I'm going to fix one thing at a time rather than a whole bunch of things, because you don't want to get yourself into a situation where you've made a whole bunch of changes and you haven't done any commits, and now something's broken, and the only thing you can go back to is the last time you did a commit, which might be 3 or 4 hours ago. So you kind of end up rethinking about how you approach programming, and instead of trying to do a whole bunch of stuff at once, you try to break up your tasks into smaller tasks. Each one of them can represent a commit. So fix this one problem, do a commit. Fix this another problem, do a commit. Fix another problem, do a commit. it doesn't hurt to have a whole bunch of commits. And as you see, it only takes just like 5 seconds to do one. You just add the file and then do a commit and write a little message to describe what you did. Once you get into that habit, it will make collaborating with other people a whole lot easier because they'll have all these little messages describing what changes you've made to your program. And none of the commits are really big. They're small enough that they're kind of self-contained. It can avoid problems if you do a really giant commit with a lot of code in there, and then somebody else does a commit with a lot of code, and now you need to bring them together, and there's a whole bunch of overlap. But if you've got smaller commits, it's much easier to manage those things. So think about doing lots of small commits rather than a few number of large commits. I understand you're a beginner. It's hard to kind of work this into your new workflow, but as you gain more experience using it, it'll become more of a second nature to you. Okay, so every time you make a change, think about doing a commit. Make a small change, do a commit, as long as the program's working. You don't want to be like that person that turns in broken code that other people are going to look at. You want to turn in a good commit that is not necessarily done, but it works and it doesn't break the compile. Okay, I can see we're kind of running out of time, so I might go over just a little bit just to be able to give you enough information to get the assignment done. So we got our files in a repository, but the files are just on a local repository. We now need to send them up to a server somewhere so that we can share them with other people, like myself, like me. There's a couple of ones you can use. There's GitHub, there's BitBucket, there's GitLab. But we're going to use BitBucket for our classes because BitBucket has educational accounts. If you sign up for a BitBucket account and use your college email address, they will upgrade you to the academic plan, which gives you more features for no cost. So I'm already signed into this, but what you'll do, of course, is you'll create an account, use your college email address, and then it'll send you one of those confirmation emails. And once you confirm that, it will then upgrade you to the academic plan. And then once you get logged in, you'll see a page that looks kind of like this, although you won't have any repositories. And you will then, at that point, create one. So you'll click on this Create button, create a repository. And it will say select a workspace. And I think now they change this every once in a while here. So there might be like a default workspace you can click, like it's your name. And so I would pick something like that. But then for your repository name, make that kind of match what you were working on over here. I call this one directory diagonal, so I'm going to call this diagonal. So make that match the name of the directory that's over here. Access level, this should be marked as private, not public. Include a README, please make sure that is set to no. And include a .gitignore, please also set that to no. It's very important when you create a repository that it be completely empty. So make sure this is set to no, and make sure this is set to no. I'm going to create a new project here. I'm going to call this Fall 2022. Okay. So once you've created a repository, it's going to say, let's put some bits in your bucket. So here, you're going to do this section down at the bottom. We already have a local Git repository. We just need to push it up to BitBucket. So the first thing it says is switch to your repositories directory. We've already done that. We are already in that directory over here, so we don't need to do that step. Next, connect your existing repository to BitBucket. You are just going to copy and paste these commands as you see them. And I think when I do this git push, it's actually not going to work. It's asking for my password. And then it's going to come back with authentication failed, even though I typed in my real password. It's because both BitBucket and GitHub and most of the other major repository vendors have stopped supporting using your account passwords as authentication. You need to generate what's called a personal access key or an app password. So here's how you do it. You go back over here to BitBucket. You go to your personal settings. And then, let's see if I can remember here, app passwords. And then you say create an app password. And then give it a label. I'm going to call this, then because I have several of these, I have to put a number off to them. It doesn't matter what you call them. I'm going to call it Git6 because I already have a whole bunch of these. And then under permissions for repositories, you're going to check all these boxes. That's all you need, just these 4 boxes checked. And then click on Create. And then it will show you on the screen a whole bunch of random characters. And so what you're going to do is you're going to want to copy this and put it in a place where you can get access to this. So I just did a copy on there. And now let's do this git push again. And then for the password, you're going to paste in that access key. And now it'll upload your files to BitBucket. Since we're running out of time, I'm going to show you probably next time how you can get Git to remember that password for you. But right now, you're just going to have to put it somewhere where you can find it, like find a notepad file or something where you can just paste that password string and then copy and paste it every time it asks for the password. Of course, now, since you all have seen my app password, the next thing I have to do after I get off the stream is just revoke that password so that you can't use it to mess around with my repositories. Okay, so if we go back over here and go back to my repositories, and I click on the diagonal one, we can see those files are in there, including, the very latest version of my desk.c. You can look at history of commits. So here it is before I did that commit. Here it is afterwards. And the last thing you need to do is make sure that I have access to this. So you'll go to repository settings and then user and group access. And then you'll say, I want to add someone to this. And you'll type in my email address. And I want you to use my Gmail email address, not my college one, because I have everything under that. And then just give me read access, that'd be fine. And then click on confirm. And it'll send me an email to have me added to your repository. It only needs to do that once. The first time you do this, it will establish a connection between you and me, and then anytime you share your repository with me from this point forward, it won't ask me for a confirmation. It'll just go ahead and do it. Okay, and then once you do that, I will get that email, and then I'll be able to look at your repository and download the files from it. So let's take a look at the assignment for this week. Okay, so it walks you through doing git config, signing up for a BitBucket account, creating an app password, and going ahead and checking those boxes. And then it has you do a git init. Actually, I think I'm going to probably update these instructions so that instead of having you do all this CD and copying stuff around, it'll just have you like open up that workspace. Then you're going to do git add, commit, and then create the repository on BitBucket, and then finally share it with me. Push things up and then share it with me. And then that's the whole assignment for this week. It's really a really short assignment. You're just basically putting all of the files related to lab number 2 that we did way back at the beginning of the semester, putting that to a directory, pushing up to BitBucket, sharing it with me, and then once I see that I'm able to look at your files, then I just mark it as complete. So this whole assignment should take like less than half an hour to do. And then starting on Wednesday, we'll start learning more about the built-in string functions. We wrote our own last week, but this time we'll use the built-in ones. And then we'll start learning about files. And this will start a really interesting part of the semester where, and there's a parallel with my other course in which they're learning right now about how passwords are stored on computer systems and ultimately how to break them, how to crack passwords. So you'll be doing the same thing. You'll be writing programs to crack passwords that have been kind of encrypted. And we'll start with a very basic version that works kind of slowly and then work our way up to a version that builds a database and works very, very quickly to do the job. And it's very, very similar to how the professional password cracker programs work. So that's what we're heading up towards. And that's probably going to occupy us for the next, probably about 3 weeks or so. And then once we get past that, it's on to computer networking. And then we'll see what we have time for at the end of the semester. Okay, so we went a little over time, but basically your assignment this week is just to get that version control system up and running, and just let me know that you were able to successfully push files up to BitBucket and share it with me. That's all I'm really looking for. If you haven't done Lab 2 yet, and really I hope you have by now, then find some other files to use. But really I'm just looking to make sure that you're able to push things up to BitBucket and share it with me. Okay, that should be it for today. Let's see if I can address some of the questions that came up. Yeah, so the question is, how do we get into the Git directory? So if you're running on a Linux system, then the cd command is how you would get into that directory, and then you can do your git init from there. There may also be a way, if you're using a graphical user interface, that you could go to your file browser, like on a Windows system, and then you can right-click on a directory, and there might be a menu that says like open terminal here or open command prompt here, and then it will pop open a window right in that spot. Kind of similar to how we did the open workspace here. What else we got here? I think that was the question that we had. Oh, Steve says, there was a change in the BitBucket UI since the instructions were written. The menu doesn't have add users anymore. Now there's a separate invite users button. Now, here's where sometimes what I see is different from what you see, for reasons that are not entirely clear to me. So are you talking about this right here, this invite? Oh,
Yeah, I think so.
And it just brings you back to this users and groups.
Right, brings you back to there. So Yeah, just so people, so that 3-dot menu, I think that instructions said to click that menu and it would have an add users there.
BitBucket changes the UI like every semester. They change
Yeah.
something in there. There also used to be a button over in this right-hand side that said add users, and it's not there anymore. Okay, so click on invite. I will update those instructions then. Anything else? Okay, well, I think that's about it for today. We'll be back on Wednesday, and we'll start talking about string functions, and then we'll start diving into files from there. And then it'll be a fun next couple of weeks. Really, really interesting stuff. And I would say the program to do the faster password cracking is probably the most challenging assignment of the semester. So make sure when we get to it, make sure you start on that early so that there's plenty of time to ask questions and get problems fixed. And it's really great if you can possibly attend these live sessions. Then we can do things like put your screen up on Zoom, and we can all take a look at your code and figure out what's going on. Because I think it's really instructive to do these kind of group debugging sessions where everyone looks at your code and we all try to look at it and figure out why it's broken and what we can do to fix it. So even if you normally can't attend these sessions, but you do have a problem with your program, then see if you can at least check in, and even if you can only be on for a few minutes, say, hey, can I share my screen, and we can take a look at it and see what's going on. All right. Well, I hope you all have a good day. Get started on these programs. This one is an easy one. It should take you no more than about half an hour or so to do once I update the instructions. And I will see you on Wednesday.
All right. See you Wednesday.
All right. Take care, everyone. Have a great day. Bye-bye.
Record.
Thanks for watching, those of you on YouTube. How many we got here? 8 people watching. That's great. I got to go get something to eat, and I will update some of those instructions. And I have so much to do as far as editing files and putting them online that I haven't yet completed putting old assignments up on BitBucket. But basically how it's going to work is I'm going to publish a repository, and then when there are new assignments, I will push the files into that repository so we'll be able to get access to them. So that's like on my list of things to do. It's just things like getting the current content up for my students is more important right now. So I haven't forgotten about you. I have started actually working on that. I don't know if you noticed, but there was a fall 22 directory in my file listing, so that's where I'm starting to work on that. But I just haven't gotten current with that yet. So I will work on that. So take care, y'all, and I'll see you on Wednesday. Same time, 9:30 Pacific time, and then we will be learning about string functions, and then we'll probably start learning a little bit about files as well. Take care. Bye-bye.